So in this video I solved the numerical problem set 9. Numerical problem set 9. So the first question is based on fault tree analysis, that is, consider the fault tree given in the figure. The probabilities of basic events, probabilities of basic events are given. Calculate the probability of occurrence of top fault event. For the top fault event, that is event dark room. So let us draw the fault tree which is given, that is dark room. So this dark room can be happen, so it is a OR gate. It can be happen either because of all the three bulbs are 3 bulb burnout. So it could be that that room is dark because all bulbs are burnout. That is one reason. Or it could be because switch failed to close. Or it could be because no electricity. Then what are the event basic causes? So maybe that room has 3 bulbs, so even if at least one bulb is glowing, then we will have light. But the thing is, so we will have dark room only if all the 3 bulbs are burned out. Okay, so which means there is a AND gate here. Here it is OR gate, here it is AND gate. So that is bulb X is burnout. So this is basic event, so it has to be in circle. Then bulb Y is burnout. Bulb Z also burnout. So if all the 3 burns, then only, so that's why it is AND event. Then so why there could be no electricity? There are again 2 reasons. Either of them can happen, need not be both at a time. So one is fuse failure. This is the basic event. Another basic event is power failure. Now the probabilities of all these basic events are given. The probability of this event is 0.08, probability of this is 0.07, probability of this is 0.06, probability of fuse failure is 0.02, power failure is 0.04, and probability of switch fails to close is also given in the problem, that is 0.05. Now we have to calculate what is the probability of dark room. So for this we have basically 2 basic equations. One is, if the basic events are joined by the AND gate, what is the combined probability? If they are joined by AND gate, what is the combined probability? That is simply product of basic event probabilities, right? And if they are joined by OR gate, then the probability is 1 minus product of probability of basic events. So these are the 2 basic formulas. So if you know this, we can calculate the probabilities from the fault diagram. So first let us calculate the probability for next level. So we have this basic event level. The next level we have all 3 bulbs burn out. What is the probability of all 3 bulbs burn out? So that would be, since this combined event is through the AND gate, so we have to just simply use the AND gate formula, that is simply product of all these three. So that would be 0.08 into 0.07 into 0.06, so which would be equal to 0.000336. You should get this value. Okay. Probability of all three burns out would be simply product of its basic events, because it is connected by AND gate. Next, let us calculate probability of no electricity. For no electricity event, if you look at, there are two basic events, but they are connected by OR gate, so we have to use OR gate formula. That would be 1 minus 0.02 is how much? That would be 0.98 into 1 minus 0.04, that would be 0.96. So this would be, if you calculate, you should get around 0.592. Then what is the probability of dark room? We have now all the basic events for the dark room, that is all three burn-outs probability we know. Now this value is 0.000336. Now we know this value, as well as no electricity value also we got, that is 0.0592, and all these three are now connected by OR gate, so we can calculate probability of dark room. So this would be equal to 1 minus 0.000336 into 1 minus 0.05 to 1 minus 0.0592. So you just substitute all the values, so you should get around 0.1065. Okay, so next question. The second question is the monthly breakdown of 127 accidents that occurred in an organization during a 10-month period are presented in the table below. Calculate the control limits. Control chart limits. Okay. So what is the data given? Month and the number of accidents. Say January, February, March, April, May, June, July, August, September, October. So this much values are given. So the values are 10, 20, 14, 12, 11, 8, 15, 15, 9 and 13. Actually, for calculating control limits, we don't need this data. Even if the data which is provided, that monthly breakdown of total number of accidents is given and total number of months is given, so actually that data is sufficient. Actually this data is given to plot the data along with the control limits. Okay, so let us calculate. So in order to calculate the control chart limits, we need to calculate mean and variance. So mean would be total number of accidents divided by total number of months. So total number of accidents here is 127 divided by number of months is total 10 months. So this would be 12.7 accidents on an average per month. Now we assume that the control charts are follow Poisson distribution. So for Poisson distribution, the mean is related to variance, that is variance sigma is equal to square root of mean, that is square root of 12.7. So sigma variance is equal to 3.56. So now we got the mean and variance. Then the limits are upper control limit, that is UCL upper control limit is equal to, the upper control limit is given by mean plus 3 times the variance. If you substitute mean value 12.7 and 3 times of 3.56, you should get around 23.39. Similarly, lower control limit is given by mean minus 3 times of the variance, that is 12.7 minus 3 times of variance 3.56. This would be around 2.01. So these are the control limit for the control charts. So let us take up the next question, third question. A process can exist in 3 states as shown in the figure. If the process exists in state 1 initially, what is the probability that it changes to other states after 2 steps? Okay, so now the figure shows there are 3 states, 1 and 2 and 3. Then between each state, what is the probability that it transition from one state to another state? Like let's say for 1 to 2 the value is given, 1 to 1 the value is given, 1 to 3 also the value is given. Similarly 2 to 2, 2 to 3 and 2 to 1, 3 to 1, 3 to 2 and 3 to 3. So these 3 values are given. So we have to make, in order to calculate probability at any stage, we have to first define the initial state. We define initial state as a vector, that is initial state vector x0 is given by what is the probability that it exists in state 1, state 2 and state 3. What is the probability that it exists in state 1? Since it is given that initially it is in state 1, the probability that it exists in state 1 would be 1. The probability that it exists in state 2 or 3 would be 0. And this is actually, we need to write it as a column vector. So if I write it as a row, then just transpose of it, or you can say it is 1 0 0. So this is the initial state of the vector. Then we need to write a transition matrix. So this transition matrix includes probability of transition from, let's say 1 to 3 states are there, 1 2 3 states are there. What is the probability that it transition from state 1 to state 1, or it will remain in the state 1, or state 2 to state, maybe you can say state 2 to state 1, state 3 to state 1. So what is the probability that it remains in the state 1? That value is given, that value is 0.9. If it is in state 1, it will remain with probability of 0.9. what is the probability that it transition from state 1 to state 2? That value is given 0.05. From 1 to 3 is 0.05. Similarly, what is the probability that it transition from state 2 to 1? So that value is 0.7. What is the probability that it transition from 2 to 2? 2 to 2 is 0, and 2 to 3 value is given, that is 0.3. Similarly, 3 to 1 is 0.8, 3 to 2 is 0, 3 to 3 is 0.2. So this is the probability of transitions from one state to another. This is called a transition matrix. Now we have transition matrix and the initial state. We can calculate the state at any time step later. So the state vector at any time later, let's say at 1, after one step, would be p into initial step. So this is 0.9, 0.7, 0.8, 0.05, 0, 0, 0.05, 0.3, 0.2. Okay, this is the transition matrix. Multiply with the initial state vector, that is 1, 0 and 0. So this would be x1 is equal to, multiply 0.9 into this, 0.9 into 1 plus 0.7 into 0 plus 0.8 into 0. This. So if you multiply this row with this vector, we get 0.9. Similarly, if you multiply 0.05 with 1 and 0, 0, so we get 0.5 into 1, 0.5. Similarly, 0.5 into 1, 0.05. So this is the state vector after step 1. So after step 1, the probability that it stays in state 1 is 0.9, state 2 is 0.05, state 3 is 0.05. Similarly, we can repeat to get after 2 steps. X2 will be p into x1, which would be, p would remain same, 0.9, 0.05, 0.05, 0.7, 0.8, 0, 0.3, 0.2. Then here x1 is 0.9, 0.05 and 0.05. So if you do this, what will get? 0.9 into 0.9 plus 0.7 into 0.5, 0.05 plus 0.8 into 0.05. Next 0.05 into 0.9 plus 0 into 0.05, 0 plus 0 into 0.05, 0. Then 0.05 into 9 plus 0.3 into 0.05 plus 0.2 into 0.05. So this is the state vector after 2 steps. Just to the calculation, you should get value around x2 is 0.885 and 0.045 and 0.07. So either you can calculate that what is the probability that it will not be in, probability that it is in not state 1. This you can write as 1 minus probability of state 1, which could be 1 minus 0.885, 0.115. You can also test it like sum of these two would be equal to 0, because if it is not in state 1, it would be either in state 2 or 3. So you can also write probability of not in state 1 is equal to either probability of 1 or it could be probability of 2, not state 2 or 3. So probability of 2 is 0.045 and 0.070. So this also you get 0.115. This is the numerical line.